I've actually got the next two full modules typed out, so Malika's got those. She's hole punching them right now, and I'll get the next ones out to you before the end of the class period. Sydney? So, we're getting going. So we're going to be graphing simple rational functions right now. And I've got the parent function, right? The toolkit function's up on the board right now, and it's the first thing in your notes, which is the simple graph of f of x equals 1 over x. And we have our graph, right? So if it says right off the bat, notice that the function itself is not continuous, which means that I cannot draw this graph without at some point picking up my writing utensil, right? I start over here, way off forever. I come in, I go down forever, and then at some point, in order to get the other half of it, I'm going to have to pick up my pencil, and I'm going to have to come back in, and I'm going to have to draw the other half of it. So this is not a continuous graph. This is a rational function. It is separated by two asymptotes. So I want you guys, first of all, we're going to get those asymptotes drawn in. Asymptotes are always drawn by dotted lines, right? So we need to draw in, we have one asymptote right here, and we have one asymptote down here. So we have a vertical and a horizontal asymptote. And those are them. Our vertical and horizontal asymptotes. So we will approach the asymptotes, but we will never touch them. Asymptotes are approached but never touched. Now notice I put a little asterisk on that, approached but never touched, because you can. There are some rare instances where you can touch the asymptote. Some rare instances. What's going to happen on those is we'll kind of cross it, and then we'll come back towards it and never touch it at that point. Those are rarer, and you're not going to see them as much, if at all, in this section. Any questions about the toolkit function? Okay. Yeah, or the parent function, that's the general graph, right? Like a parabola, we all know looks like that, but I can make it skinnier, I can make it fatter, I can move it up, down, left, right, flip it around, right. But that is the parent, the toolkit function, like the basic. The control. Yeah. I like that, the control. All right. In the standard rational function, the asymptotes are at the x-axis, which is y equals 0, and the y-axis, which is x equals 0. Just like our previous functions, rational functions can be translated, dilated, reflected. We simply need to know what's considered inside and outside the function, right? Because when we have inside stuff is horizontal, outside stuff is vertical. So when we want to talk about what's inside and outside the function, we have our basic one. Now, once again, this should look similar. We've done this at the first section of every module we've had. Layla, I know you're coming in late. Marion, same thing. But, so what's going to happen here? Josiah, what's my A doing right there? Stretching it which way? Vertically. This is vertical and horizontal stretches. Actually, let me cut this over. Yeah, it's the same thing over and over. Same thing over. Holy smokes, what did they do? Bethany wrote something. I don't know. Maybe I should take a look at what they did the last 4 days. It was math.
This is ours. The first 2 pages are ours. Oh, true.
Wow.
No, it's not ours.
This is 6th period. The first 2 pages were your guys'?
Yeah, simmer down. Well, there was
go down.
The
next page has more, I'm pretty sure.
Yeah, I think so. Go to the next page.
Okay, like this looks really bad.
There we go.
This is ours.
This right here.
I know, I did 2 or 3 of those.
I did
3.
Yeah, so you did like.
Because like I thought.
Oh, me too. So we did more than they did.
Period. Cameron's name is just common.
Remember 6th period had internet issues, so they took longer on their tests.
No.
These were for the test.
Those were for the test. Those were for your diffraction thing. No, I know. I was saying like that was for Friday, right? So. I don't know. I'll take a look. My wife was supposed to write down names and stuff, so we'll see.
No, we had Miss David. Yeah, it was Miss David.
Oh, this was Tuesday. Oh, okay, that's right. I was here. I was dying. Okay. All right, guys. So let's quiet back down. Okay.
That's when Mr. Bates hurt my feelings.
What?
When I told him I loved him, he was feeling bad over there. He didn't acknowledge me.
Okay. So we have our plus or minus A. The A is our vertical stretch or compression.
That was you on Monday.
That was me Monday. You should have seen me fourth period. It was terrible.
Did you stay the whole day, or did you leave early?
No, I stayed the whole day. I tried calling my wife in. I was tapping out all day long. She was like, "Suck it up, Buttercup," and I'm like, "Ah."
Hey, yeah, you know how many times she said, "You should have got your flu shot."
Oh my gosh.
She's like, I told him he should have gotten his flu.
Oh my God. Okay. I don't need to hear. Yes, Malika. Oh yeah. Yeah, do the same thing with those. Okay. All right, Stephanie, if this is a minus, what's going to happen? What's the minus going to do if that was a minus in front of it? It's going to go down. Jaden? Reflection. What kind of reflection? Vertical. It's outside. Vertical reflection. Okay. Samuel, what's my H going to do? Horizontal what? Nope. 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 Translation. We could have just said left-right movement, right? We could have said this moves it left or right.
And this one, like, HK is the center point.
Yeah, and we're going to discuss what the center point means, right? Because in a parabola, my HK defined the vertex. In a cubic, my HK defined like that point of inflection, right where it turned. My watch keeps thinking I'm talking at it. So we're going to get flow. Give me, what's my K do? Up, down. Hey. I could tell I was looking over at him and he was just like, I know this. Mr. Bates is going to call on me. I got this. So this should all be familiar to everybody except for my two students who just came in, whether or not they have this down. Layla? Marion? Okay.
Yeah, that's a compliment. I just was so used to you here.
Yeah, you're already his brother. Okay. We already know all that stuff. So that's all written down right here, guys. Left, right, up, down, all that good stuff. Okay. So the HK, actually, do you guys have some room in here still to write a bit? Let's get one more thing written there, huh? So HK determines where the asymptotes cross. HK determines the coordinate where the asymptotes cross. So in our parent function, in our toolkit function, the standard 1 over x that is graphed at the top, where do my asymptotes cross at? You can look at it. Where do the asymptotes cross on that? The dotted lines, where do they cross? That's 0, 0. They cross at the origin, right? So wherever I've shifted this to, if you graph the dotted lines first, everything else comes into play pretty easy. Yeah.
I got mixed up. Okay.
That sounded like gum popping. That wouldn't happen on this campus, would it?
Yeah, Martina.
What? Of course, Martina, of all people, knows the rules better than anyone. That she shouldn't be on her phone during class ever.
Using
And she never would. I'm saying what you would never do. Right. Right. And she would never chew gum on campus. Okay. Okay. Oop. Change it. Shh. Guys, don't use that word, please. Okay. All right. All right? Okay. So here. There is one thing I'm going to show you guys right away on this one. When you have a number in the numerator, we can easily turn that into an a value. That is going to be our a value. So the first thing, if I wanted to look like the standard function, I can pull this out. Yes, I can rewrite it like this, so that way I can see what my a value is. Okay? Alexa? These are the same thing. I'm just showing you that 4, that numerator, represents the a value. Okay? And I can show that by simply pulling it out if I want to, and I really haven't changed it. So where will my asymptotes cross at, Josiah? -2, -5. Remember that h value is opposite. So my center is at -2, -5. Remember, you go against the h value, you go with the k value. What was that? So, since this is inside the function, it's going to represent horizontal movement. And since it's occurring first, I need to undo it, basically. That's kind of what's going on. So this means 2 to the left, not 2 to the right.
So when there will be minus, it will be to the right.
Correct. So here are my asymptotes. Here are my asymptotes.
Yeah.
So I will approach and never touch those lines. So now how does how do I represent that vertical stretch? So I'm going to go back to the first example that we have, and we're going to talk about how that vertical stretch works. And it's very, very easy to apply. I didn't bring it over. Okay. Let me just let me copy it from over here then. There it goes. All right. So here's our toolkit, our parent function, the basic one. This needs to somehow be vertically stretched by a factor of 4. And how does that happen? It's pretty easy. This hits at 1, 1. Do you see that?
Yeah.
And do you see that now, and this hits at -1, -1? Mm-hmm. And can you tell that it is symmetric around that dot?
Yeah.
Okay, so the curve here and the curve here are identical. Yeah. So what's happening is I'm going to take that curve and I'm going to be stretching it this way and this way the same amount. So I'm basically stretching it like this. Okay? So instead of out 1, up 1 and having that dot right there, you follow me so far? I'm going to vertically stretch by 4, which means from this dot I'm going to go up 4 over 1. Not done yet. Go ahead. I'll let you guys get that dot in there. Yvonne, so from the center here, if you can't tell, I went over 1, up 4 from it. Okay? But now this is just like this one is symmetric. It's symmetric. Right here and right here are the same type of curve, right? If from that dot I went up 4 over 1, I'm also going to have to go to the right 4, up 1. So, because I've got to keep that symmetricness. I've got to keep that symmetricness.
Point should be lower because it's at
2 minus.
I think they're not above.
No, that's where it's supposed to be.
Oh, I'm put my dot.
Okay,
Wait,
Madeline, Florian. Yes.
that's where the line would go.
Right, so now I'm going to draw a curve, and it's going to cut between to those 2 points pretty quick. So, I mean, this is to the best of your ability.
Wait, but then
Yeah.
so technically you wouldn't be able to draw the other one.
Yeah, no, I will. So I'm going to go, I mean, I'm not going to be able to, yeah, the second dot I'm not going to be able to get. Yeah, I mean, this is sketching to the best of your ability.
I'm not saying it's perfect.
Yeah. Yes. You went last period, huh?
It's left 4 down 1, right?
Yeah, you're going left 4, down 1. Yes. We all right so far? Let's get, yeah, I've got some more examples in here. Okay.
Wait, which one's that one's about?
The one with the blonde white dude has like a little white dog and they go on adventures. Yeah, they go on adventures. What? Tintin. Adventures of Tintin.
Yes.
When do we get tacos?
Bruh, I remember for a while.
Like, yeah, it was like movie.
No, I don't have a date super in mind. I want it to be, I want it as soon as possible.
What about Friday?
I don't know if I can pull it off by Friday. Because I'm either, yeah, that'll be hard, but we'll see. Okay.
Well, in the movie he was small.
All right.
In the comics, he's small too.
No. He's a redhead. He has a redhead.
He's a redhead in the comics. Tim. It's not Tim. It's Tintin.
Gentlemen, lady, let's quit worrying about this movie. So, let's go ahead and write down, what is our vertical asymptote? The equation of our vertical asymptote for this, it goes through -2. What equals -2? X equals, thank you. X equals -2. What is my range? Now, this is a very, 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 very important, because what does range mean? I don't know why I've got those. These are kind of swapped around too. Let's fill it in slowly. What's my horizontal asymptote? Y equals -5. So, unfortunately, like, this should go with my domain, and this is going to go with my range, just so you understand which one affects which. So my vertical asymptote affects my domain. My vertical asymptote affects my domain, because an asymptote is a line that you're never going to touch it. Okay, so what is my domain? Go ahead, Sydney. You're good?
Domain.
Yeah, the domain. X equals -2 is where the asymptote is.
You gotta do
We'll do it. We're going to do it all 3 ways.
less than or equal to, but it can't.
But you can't touch it, which means we're not going to have the equal to.
So it's just
So X is less than -2. but it's also greater than negative 2. The other way, it could be anything. If you look at, let's look at our graph. It can be, x can be anything to this side. That's less than negative 2. X can be anything to this side, greater than negative 2. It cannot be negative 2. Another way we can write this, let's be very clear. Another way we could write this, or we could just simply say x can't be negative 2.
Wait, is that an X? What is
X cannot equal. It's an equal to sign with a slash. Okay? Those are the two ways we can write it. We could say x is less than negative 2, and x is greater than negative 2. So it should be an and.
So the next one, y can't be negative 5.
Right.
Y can be less than negative 5 or y is more than negative 5.
Right. And guys, I understand one way of writing it is easier than another way of writing it, but it's important to understand every way to write it so that way when we're taking these multiple choice tests and we see different options that we understand what means what. Sydney, don't worry about the movie. All right, 8-1, complete 1 through 3 in your workbook. We'll say 5 minutes.
Wait. Can I get a new one?
What? No. Why? You've got... it's whatever 8-1's at. Look for 8-1 up here. 27? 47.
Can we use it here? This is 1 through 3 in your workbook.
Yeah.
So we can do it here, right?
No, get your workbook out and do it in your workbook.
Wait, but it's the same.
No, it's not.
Oh, this just means like when it goes right.
Yeah.
What am I gonna do with this air cover? Leave it on there?
Okay, so Mr. Gay, I have a question. I'm confused.
That's not a question, that's a statement. Okay, so let me go ahead and run through these.
Wait, why did you have this red drum?
All right, so the first thing, a few of you guys know, Leticia, what do I do with that 2? Yeah. Marion's right. I'm going to put it out front so I recognize it. I recognize it as my A value. So what is that 2 doing? Vertical stretch by 2. Okay. And then the 4 is moving it left 4. Left 4. So describe the transformations. Describe the transformations. It's a vertical stretch by 2, and it's been moved left 4.
Just another question.
Yeah,
Again, how would you know it's a stretch if it's
bigger than 1. It's a stretch if it's larger than 1. Okay? Okay. All right. So guys, I'm going to put my dotted lines. Here are the basic dotted lines on the toolkit function. But it's being moved. It's being moved to the left 4. Ta-da. Okay? So those are my new dotted lines. My new dotted lines have moved left 4. And then I've got a vertical stretch by 2, which means from that center, I go over 2, 1, over 2, 1. So I need to make sure I hit those 2 dots right there. Question? Gabriel? Huh? Oh, That is incorrect. Thank you. Sorry, I reflected it for some reason. I shouldn't have done that. My mistake. Okay. Alrighty.
So technically, these are all way different.
No, so Sione called me tiny. Sione called me tiny.
Okay. And then my terrible sketch to the best of my ability. Okay? So from that dot, and once again, they do that annoying thing where they're counting by 2. So when I go from that center, I go up 2 over 1. I'm kind of in that middle point because they counted by 2s. It's really obnoxious, but whatever. Any questions on number 1? Okay. 2 and 3. These go much faster.
I'm gonna be a Spanish rapper.
Okay. So, vertical asymptote, yes. Vertical asymptote at x equals right, we go just to the opposite, remember? Horizontal asymptote. Right, on the outside stuff, we go with the actual number. So vertical asymptote, x equals 3. Horizontal asymptote, y equals 5. And then our domain goes with our vertical asymptote. Yeah, we'll make our lives easy. X cannot equal 3. Yes. Y cannot equal 5. So, Patricia, going off the same type of format, what is my vertical asymptote here? Yep. Vertical asymptote equals -8. Evie, my horizontal asymptote. Y equals -1. Give me full sentences here. Y equals. And then our domain and range, I'll get lazy. Okay. Yes. Yeah. Alrighty. These next ones, long-ish. Okay. What? What, Sydney?
He called me stupid.
Sydney, let's try not to call names. I think it's a little beneath us all.
I get called a name. Okay.
Sydney? Just because it happened to you, does that mean you should do it to other people? Okay. Hey. It's not lotion class.
I was wondering how you kept it so shiny.
Hey. All right. Smells good.
Play-Doh dolls, you just like.
Okay, guys. Identify the transformations graph using the reference points. That's what we've already been doing. But I wanted to get some funky ones in here, all right? So this is going to be the exact same thing, but we're also going to state the domain and range. I wanted to bring it back. We're going to use because they're going to ask for it in your homework, and I want to remind us how to do it. So we're not going to be allowed. Well, we can. So we can with set notation. Set notation, which in the past has been the longest one. Set notation is going to be the one that lets us use the does not equal to sign. Set notation is going to let us use the does not equal to. So this is going to be almost the same thing. So what am I going to pull out front? Josiah? 1/4. I will pull the 1/4 out front. Okay. And why does that work? When we multiply fractions, how do we multiply fractions? Gabriel? I don't know what you mean by that. I mean, it's a very simple answer. Leticia? Yeah, the numerator by the numerator, the denominator by the denominator. When you multiply fractions, you just go straight across. So, of course, what's 1 times 1? What's 4 times all that? 4 times, yeah, 4 times all that. Okay? So, of course, I could just pull that 1/4 right out front. So now I know my A value. So we're going to describe all the transformations. First thing, and now the two people who are new, that negative, guys, what's the negative do? Vertical reflection. So first of all, that negative sign is a vertical reflection. That's where that came from. Vertical reflection. 1/4, is that bigger than or less than 1? Less than. So what's it going to be? What kind of compression? Vertical. Vertical compression by 1/4. This could have also been, if we wanted to, if we could have left the 4 underneath, a horizontal stretch by 4. Exactly. It could have been written as a horizontal stretch by 4 if we wanted to, right? The way I explain that one is, once again, actually you brought up Play-Doh. If I have a ball of Play-Doh and I pull it this way, right, it gets taller, but what happens to the center of the Play-Doh? It gets thinner, right? And if I squish Play-Doh down, it gets shorter, but what's going to happen out the sides? It gets fatter. So vertical stretch creates a horizontal compression.
What if you eat the Play-Doh?
Then you're gross. Okay. 2 to the 2 left. 1 down. That's just horrible. Okay. Yeah. Well, we'll draw it in a second. Domain and range using inequality, set, and interval. Okay? All 3. Actually. How did it order inequality set? Yes.
You got visitors.
I can't hear you. Oh, sure.
Can I go to,
Inside of my door? Cool.
can I go to the blood drive?
You are old enough and fat enough, yes. So. What, there's a weight requirement and there's an age requirement.
Well, I've been giving blood for it every year, and I'm not getting paid for this.
They don't give you donuts?
Oh, they give you all sorts of snacks. Okay. All right, guys. 5 minutes, you guys need to focus up. So that way we get this problem done here. Okay. Because I want to make sure there are no questions. So the inequality notation, guys, if I'm literally asking for the inequalities, I want the less thans, greater thans, all that good stuff. So the domain, I can't equal what number? Where's my vertical asymptote at? Negative.
Cannot equal -2.
-2. So x is less than -2 and x is greater than -2. That's my inequality. My range, I can't be what number? -1. So y is less than -1 and y is greater than -1. We'll come back to set in just a second. Set was what you guys, if you don't recall, set's the one that most kids like because it's the shortest. But there's going to be a little bit, it's going to be a little different this time. So my interval's got the brace, if you don't remember, what people would refer to sometimes as the curly bracket. Okay? So my interval is x such that x is not -2. Interval is going to let me use, that's set notation, you're right, that's set. I apologize. Good job, Josiah. Whoop.
I'm so glad I didn't write that down.
Interval is what you guys considered the easier one, yeah, in the past. So that one just has the brace. We define the letter we're talking about. We put that such that bar. And then we know what our, hopefully, we know what our y is going to be.
Yeah. Oh, wait, but this one's going to be harder because then you can't.
So, the interval notation.
Can I have a guess?
Sure.
Okay, so parentheses.
Parentheses.
Wait.
Negative.
Yeah, negative infinity.
Negative infinity. Good job.
Comma.
Comma.
-2.
Negative 2.
And then the bracket thing.
No, parentheses, because I can't equal -2.
Oh, yeah, yeah. So then the other one, it just goes -2.
-2.
And then positive infinity.
Positive infinity. And I'm going to put a union between them because I need them both. Good job, Alexa. Impressive. Period.
Only y'all would laugh at that.
You didn't expect me to get it
I
right?
thought that was calm.
You nailed that. I'm sorry. That's a hero point right there.
Oh yeah, good job, Alyssa.
You know, I would actually help my dad with class and she would get the hero points, but he actually doesn't give me any hero points.
Yeah, I don't. I don't. So, all right, guys. Last little bit here. Let me get this in. I moved it left 2, down 1. That's where my dotted lines cross. All right, left 2, down 1. Now, unfortunately, I've got a compression by 1/4. So it gets even tighter to that corner. So I'm only going to go over up 1/4. And then over 1. So instead of up 4 over 1, it's going to be up 1/4. It's just going to be, well, it's 1/4 away. So, I mean, honestly, I'm just going to make this super tight. 2. And it's reflected. It's reflected. That's why I drew the more I drew them. Okay? The 1/4 does make life really difficult to draw those in. All right. We're going to finish this tomorrow, and I actually have your homework sheets printed out, so that way when you come into class tomorrow, you'll get started. Yeah. Sorry I missed last week, guys. Happy to see you all. No homework tonight. You'll get it tomorrow.